Who of you knows KubeVirt? Hands up. So, who have used KubeVirt already? Okay. We think KubeVirt is quite an interesting project. It lets you modernize your infrastructure, lets you modernize your workflow. So that's basically the reason why we had a deep dive into the technology the last few months. And what we're talking about today is the challenges of traditional virtualization solutions, short KubeVirt introduction, as well as a look at the architecture and the basic concepts behind KubeVirt. We have a demo for you and some potential use cases where KubeVirt fits in quite well. So the current challenges of traditional virtualization solutions. One good example is the acquisition of VMware by Broadcom. So that's the reason why there's a lot of movement in the market currently. Organizations are searching for different solutions, how you can manage virtual machines. Another one is two stacks. So you usually have to build one stack for the virtualization infrastructure and one for the container workloads. And they quite differ a lot. The cloud native adoption, we have a lot of pipelines, we have a lot of automation in the cloud native world, but it usually stops at the gap between the cloud native platform and the virtualization platform. So short introduction, let's have a look at the evolution. Decades ago we had that one server. We installed several apps on the server. Then sooner or later, they started to clash because of resources or maybe different needs for dependencies. What we did is we put in virtual machines. So we had a big server. We sliced them with a hypervisor. We isolated our system. We made a smaller isolated system with all having their own operating system. Then, whenever you wanted to scale your application, you maybe wanted to have microservices. It didn't really make sense for them to all have their own operating system. So that's when the container platforms kicked in. The main difference is they are not having their own operating system. So a container is actually one process on the host system, and it's mainly process isolation. It's not like system isolation like a virtual machine. It uses technologies like namespacing or control groups from the kernel to isolate the processes. Whenever we have a look at KubeVirt, KubeVirt is actually using KVM. It's part of the Linux kernel. So it's a hypervisor, actually almost 20 years of life. So it's quite battle tested, it's performant. It's important to know KubeVirt is not really something new. It's not a new hypervisor. It's just a way to manage virtual machines on Kubernetes. One important thing with KVM virtual machines is they are running as regular processes on the host system. And we know containers are actually the same. They are processes on the host system. So we can put them in containers as well. They even have the same requests like compute, like network and storage. So there's no reason why we could not wrap a container, virtual machine in a container. So what is KubeVirt? KubeVirt is a Kubernetes extension that allows running traditional VM workloads side by side with container workload. That's true, it's a good definition, but it's more like a human definition. So for the technical aspect, it's more like KubeVirt is an extension that deploys a virtual machine wrapped in a container. So from the Kubernetes perspective, there are only pods and containers. Kubernetes doesn't know anything about running a virtual machine somewhere. It's just pods. KubeVirt project itself, it's founded in 2016 by Red Hat. It's currently a CNCF incubator project. It's fully open source. It has a quite growing community with over 300 contributors. And also the big players like Red Hat, NVIDIA, Cloudflare, which mainly put in the innovation and develop the project. Short side note, whenever you are not comfortable with running a community-supported project like KubeVirt, there's OpenShift virtualization. It's based on the KubeVirt project, and you got enterprise support from Red Hat. So that's an option whenever you like to have a supported product. So the basic architecture concept, there are mainly two fundamental design decisions the KubeVirt team had to choose. They said they want to use the operator pattern from Kubernetes, and they want to use the declarative API, like specifying resources in a YAML, like custom resources. So they want to be fully on the side what Kubernetes provides per default. As well as they want to be based on the standards. They didn't want to reinvent the wheel. There's a project, Virtlet. You basically have two ways of running virtual machines in Kubernetes. You can build a custom container runtime, which does the magic for running virtual machines in Kubernetes, or you can use the basic set and wrap around some logic with controllers to spin up the machines. And KubeVirt decided that they want to go the standard way, so they can use every feature from like a storage provider. They can clone disks, they can use snapshots, and they don't have to reinvent it in their custom container runtime. The KubeVirt operator actually puts in a lot of new custom resource definitions, like a virtual machine. It's mostly the most important one, a virtual machine instance, which is a running instance of a virtual machine. And whenever you want to scale your virtual machine, you may most likely use a virtual machine pool. So that are resources introduced by the KubeVirt operator. On the right side, it's a sample how a KubeVirt virtual machine can look like. So it feels like any other Kubernetes resource you know already. From the runtime perspective, on the left side we have the cluster level part. You have a Virt controller, you have a Virt API. The Virt controller is the controller implementation of the operator pattern. So he has a look at what custom resources are in the cluster, how do I have to react on these. The Virt API is responsible for any virtualization related workflows like starting, stopping, virtual machines, as well as validating custom resources. That's the job of the Virt API. On the right side, on the node level, we have one component. It's running as a daemon set. It's the Virt handler, which does the magic around starting virtual machines on nodes. Important to know, for the scheduling, there's no change with KubeVirt, so it's plain basic Kubernetes scheduler. You can use everything you want, like node selectors, taints and toleration. There's nothing special with KubeVirt. So whenever we want to create a new virtual machine, we put on a custom resource like my VM virtual machine, and the controller has a watch on this resource. He actually has to decide, oh, for that virtual machine, I need to spin up a pod to host the pod on the node. So actually the kubelet starts my pod, and at this stage there's no VM running inside the pod. It's just basic tooling available in the pod, but the VM is not yet running. In a later step, the Virt handler kicks in. He has a look at the pod spec. He uses the Virt API, the API server, to get the definition, to see, oh, what I have to do with this pod. And he actually talks with the Virt launcher pod and starts that process inside the pod. That's how pod VMs are started inside Virt pods. So for running a virtual machine instance, what do we need? Obviously, we need some disk to boot from. You can migrate the disk. You can import the disk from your legacy system or traditional system. You can use like the containerized data importer. That's actually also an operator, an independent operator, but also under the hood of the KubeVirt project. You can use it for cloning disks, creating blank disks, even basic migration, like taking a disk image from VMware, converting it, and putting it in a persistent volume to boot from. Also important concept is using ephemeral disks or container disks. Container disk is like a disk which is distributed using a container registry. You can whenever you start with a container disk, it downloads the disk image, extracts it, boots, and then whenever you shut down the machine, it's gone. So it's deleted, it's ephemeral. Or there are some public images like from Fedora or Ubuntu, which they provide as KubeVirt images which you can use. There's another way. Maybe for container disks, like ephemeral disk, you want to use general disk images, and you want to customize your image whenever you start your VM, so you can use Cloud Init or Ignition and sysprep for the Windows images. So it's like configuring your disk at boot up for your machine. For the migration, I told the containerized data importer is capable of converting disks, but it's not really helpful if you want to migrate large environments, because you usually have to map networks from VMware, for example, to networks in OpenShift, or for the storage mapping. There's a project called Forklift Operator. It's part of the Conveyor project. It actually helps you to map these resources and to do like planning a migration and then running the migrations. So it's quite nice. It's available as a migration toolkit for virtualization whenever you are using the OpenShift virtualization part. Yeah, then I'm handing over to Thomas.
So let's hope the demo goals are good to us today. Before we start with the demo, I would like to show you a little bit of the setup which we're going to go through in the next couple of minutes. So we're having a Kubernetes cluster with bare metal nodes running somewhere on someone else's computers, obviously somewhere under a desk or wherever, but they really are bare metal nodes. And what we are going to do is we will deploy a Fedora virtual machine to this bare metal 0 or bare metal 1 node to our Kubernetes cluster. Within this Fedora VM, we're going to install Nginx web server running on port 8080. And we're obviously going to use this Cloud Init scripts, which Rico mentioned before, to configure and to provision those packages there. Then we're going to integrate into the Kubernetes world, so into the standard Kubernetes world, and we want to make sure that this Nginx running on port 8080 is connected to a service, Kubernetes service, the network part, and also is going to be connected to the internet so that we can like serve, in that case, a website in the internet to provide the functionality to really introduce those two worlds into each other. So we'll be having a Fedora VM running on a bare metal node, which is connected to the pod network of Kubernetes, which then is exposed as a service and ingress to the internet. And what we now then are trying to do is like to live migrate. So this is a concept we have in the traditional VM workload space, that we can live migrate running VMs from one node to another. We'll be doing exactly that on our demo setup. We'll be live migrating this running VM with this Nginx container running in it from node 0 to node 1 or the other way around. And all the while we do that, the requests from our service here, which will be running from the outside, should still return some value. Let me quickly sit down so that I can start with the demo. So before we start, as I mentioned before, we have this cloud init file. This cloud init file is basically a configuration, a provisioning method on how we can configure our cloud, our container disk. In our case, we set a very famous password, KubeVirt. We make sure that the password doesn't expire, and we also can tell the virtual machine when it's starting up and running this cloud init run that it should install some packages. In our case, obviously, we'll be installing the Nginx package, and we can then, with this write files command, basically configure our Nginx package. The most important part is down here. We expose port 8080 within the virtual machine, and whenever a request hit our root directory, will return hello meetup message to the outside world. Obviously, in the virtual machine world, in the Linux world, we also have to make sure that this process, this Nginx service, will be enabled and started. So whenever the virtual machine starts, the Nginx gets started as well. Next, what we are going to have a look at is the virtual machine manifest. So as Krigo mentioned before, it's basically a custom resource which we can apply to our cluster. We can simply apply it to our Kubernetes cluster and make sure that the VM will then look like we specified. For example, the volumes down here, as Krigo mentioned before, also we will be using a container disk Fedora image, which is then configured by our cloud init user data file, which we obviously, since it's containing a password, so confidential data, will storing this data inside Kubernetes secret. So basically we show like the two worlds already work together on a VM level from configuration perspective. There is also other possibilities we can configure on our VM, for example, the resources or the whole networking stuff, but we're not going to look at it right now. So I've already applied this resource to our cluster before. We can see now we have this Fedora VM in state stopped, and when we want to start it, we can simply use the virtctl command, virtctl start Fedora VM command to start, to make sure that the VM is started. A running virtual machine is not represented in the virtual machine manifest, but rather in the virtual machine instance manifest. And when we have a look at the virtual machine instance manifest, then slowly the VM, when it's starting, it gets created. It also gets allocated a network interface, in our case the pod IP address, and it's allocated to one of our nodes, to the 0 nodes, to our bare metal 0 node. Also, what I want to show you is there is obviously, as Krigo mentioned before, also a pod running. So this Virt launcher Fedora VM pod is the actual pod with the process in it, where the virtual machine is running with libvirt in it. So you can really also handle the stuff like you would handle Kubernetes things. The reason I'm talking a bit longer is because the cloud init script is running in the background. So whenever we now connect to our console, virtctl console, Fedora VM, the startup of the cloud init run should be done, and we can simply log into our virtual machine now with Fedora and the very complicated password, which I'm not hitting. KubeVirt. I should not talk while entering stuff. So we can see now I'm logged into my process running on Kubernetes on my virtual machine. I can also see with, not this one, that our Nginx server is running already on the machine, and obviously I can curl my local web server and see hello Meetup would be the answer here. So, and whenever now we want to like make sure that it integrates into the classic Kubernetes world, we can simply apply this resource here. So the service which exposes the 8080 port to our internal network, and also simply add this ingress which configures our web server running inside our VM to run on our to be available on the internet. Obviously, hello, Meetup should work once again. Very well, so let's now try to do the live migration. Before we start, I start a loop here, a curl loop, where I hit basically once in a second, I hit our virtual machine from the outside. As you can see here, it's the outside URL starting. And while we do so, I will then, let me quickly show you the VMI again. I will then start the live migration. So currently this virtual machine is running on bare metal node 0, and I can once again use the migrate Fedora VM command to start the migration. When we watch our VMI instance now, we can slowly see that it starts to update, and what you guys will most probably observe is that the node name here will change and the IP address will also change. So what's now going on is basically KubeVirt transfers the whole state of the CPU, the whole state of the VM running as a virtual machine on node 1 or 0 to node 1, and really quickly spins up on the other side. We've seen a short disconnect here. That's the reason why we're using pod network at the moment, but it went really quick. So it was in a matter of seconds. The running VM was transferred from one node, physical node, to the other physical node. With that, I conclude the demo, and I'm glad it turned out to work, which is always a good thing to be in live demos, obviously. And I would like to show you now some real-life use cases which uses currently, or where KubeVirt is in use currently. So the most famous one probably is GeForce Now. GeForce Now runs on KubeVirt, and GeForce Now is basically a PC gaming everywhere service. So from NVIDIA. What they do, they render the graphics for high-quality PC games in their data centers on a KubeVirt cluster, and they basically stream the video gaming stream back to your living room, where you have like basically low-powered devices, for example, just a simple device to, or even your TV to display these streams, these gaming streams. And it's huge success, obviously. And what it really uses is this direct access to hardware, because they obviously have lots and lots of those GeForce graphics cards running connected in their KubeVirt cluster. Another very interesting use case is Cloudflare. Cloudflare provides development environments and build pipelines, build environments for their teams so that they can develop really close to Linux server stuff, so they can test and build kernel testing stuff on their KubeVirt platform, and really make it easy for their teams to provision their own development and build environment. Obviously, as Gregor mentioned in the beginning, standardization and modernization is a work or a use case as well. We currently have 2 stacks running. We most often also have 2 teams. One team is more for the VM workload, the other team is more like taking care of the container workload. There is different knowledge needed, often also different logging solutions, metrics, technologies are needed. And with a converged infrastructure, when we bring that stuff together, we can like combine knowledge, know-how, and obviously also resources to make sure it runs together. I will talk a bit more about one-on-one migrations of the traditional workloads to KubeVirt later, but that as a very interesting use case for many customers here, and many more. So it enables application migration and modernization, so you can basically use those fancy new cloud-native processes to manage your traditional workload on premises. So you have tools now where you really can use and run modern VMs on your own stack. Obviously, as Gregor mentioned, the license stuff, it will reduce vendor lock-in at the high amount. So we're using an open source technology instead of the traditional virtualization stacks. You can really tightly couple to your hardware. So if you have like tight coupled workload to your hardware, it enables you to give a more modern way of doing stuff. And as we've seen in the demo, it's easy integratable into the container world. So you can really run containers and virtual machines side by side and also benefit from each other. It makes it a lot easier to work with virtual machines. That being said, let's come to the conclusion. KubeVirt is really fancy and I really like it. It's a lot of fun. It makes working with virtual machines really interesting for us as cloud native engineers. But there is a but. So it's not designed for every single workload. It's basically mostly designed to run on bare metal on premises in your data center. When you would like to run virtual machines on the cloud platform, it doesn't really make sense to have this additional layer in between, which is called KubeVirt to stage to manage those virtual machines. It would rather make sense to like use the API or something like Arno maybe is going to talk about in a little bit. And the one-on-one migration really is a point that is interesting. So if you put in a lot of effort into migrating VMs from a traditional hypervisor to a KubeVirt-based hypervisor, this will cost you a lot of effort and you might not get the full benefit out of it. We have seen before small VMs, short startup times, low footprint, using container disk, cloud native approaches makes it really fast and nice. If you just put the old VMs we have, which were like managed over years to such a platform, you might not get the full benefit out of it. So you need to change not only processes and tools, but also you need to change your virtual machines. You need to adopt your virtual machines, make them more modern. And if you do so, why wouldn't you just move this workload to the cloud somewhere on the cloud platform? Obviously, there is a niche where we would like to have such workload running in a data center, but there are also other solutions you could do that. And you need to change. The organization need to change to be able to produce cloud native virtual machines and also to use and adopt those processes we have to get the full potential out of such a solution. That being said, if you want to get your hands dirty a bit more and learn how such platforms would look like and would work, we provide these OpenShift virtualization labs twice in January. There'll be a half-day hands-on labs for you guys to explore and to learn OpenShift virtualization. You can register on our website. It's based on our 2-day training, which we provide in terms of OpenShift virtualization and KubeVirt. And it's for free, obviously. Come and join the community, learn a bit more about cloud native virtual machines on KubeVirt and OpenShift virtualization. That being said, we're a cloud native engineering company from Bern. We help customers like Suva on their way into the cloud native world. And we really enjoy being part of this awesome community. My name is Teemu.
My name is Gregor.
And it was great to have you here. Are there any questions? That's wonderful. Even better. Thank you very much.